Picking up where we left off, we're going to jump right to page M3-127, and we're going to solve these multiplication equations without models. So remember, our goal is still the same, our target is still the same, is to be able to solve one-step equations, okay? So we're going to solve these multiplication equations in models like you did, and you can also use the properties or rules of equality and inverse operations to isolate or get that variable or letter by itself, because what's on the other side is going to tell us the answer. So the inverse of multiplication is going to be division. Let's take a look at our worked example on page M3-127. We have a rule here, the identity property of multiplication. Now, I want you to think about the word identity being who you are. So who the numbers are using multiplication. So that means m times 1 equals m. I've already been talking about this to introduce this to you. It really means any number times 1 is going to be that number. It's going to be itself, okay, its own identity. Multiplying it times 1 does not change it, okay? So we're looking at 4 times something r equals 32. Okay, so what they're doing right here is they're rewriting it with that 1r. 4 times 1 is 4. So then look what they've done next. They wrote it with a fraction bar, but remember that means divide. And when they took that 4 over here, see how they broke 32 already into 4 and 8, because 4 times 8 is 32. Okay, so then when they divide it by 4, these 4s are going to cancel or become 1, leaving the 8. So then when the 1s go away, we're left with r equals 8. Okay, and that has to do with the identity property of multiplication. Now, what I want to draw your attention to is you can always check your solution or your answer. So we think the answer is 8. So instead of the r, remember it's 4 times r equals 32, we're going to replace the r with our answer. Is 4 times 8 32? Yes, it is. So that is true. So we know we are correct. Okay. Are there other solutions? So it repeated everything here again. We're answering 1B. So let's take a look. Anything else times 4 is not going to get us 32. Okay. When you solved this, there's only one answer. Now, later on, you're going to learn other ways where there's going to be more than one answer. But for now, in 6th grade, we only got one answer. So we know no, there's no other solutions. And because we only got one answer, okay, to our problem. Okay, that's how we know right there. Okay, let's try another example. Use the same strategy. So remember, this is 8 times a equals 72. So the opposite of multiply is divide. Remember, we were putting this line here, doing the same math on each side to keep our teeter-totter balanced. And the fraction bar means divide. Okay, so we divide by 8 because we are isolating or getting a by itself. And if I have 8 divided by 8, the answer to that is going to be 1. So I have 1 times a equals, well, what's 72 divided by 8? I believe that's 9. Okay, so remember that rule that we just talked about. The identity property of multiplication, it says 1 times anything is just going to be that letter, number, whatever it is. So we got the answer is 9. Let's check ourselves. 8 times something equals 72, and we think it's a 9. So 8 times 9 equals 72. Is 8 times 9 72? Yes, it is. So we can see that they are equal. Yes, it is a solution or an answer. Okay. Same strategy. 11 times t. So, I mean, we're at a 3.0 all day long here on these practice problems. Okay. The opposite of multiply is divide by 11. divide by 11. So I have t. Now I just have to figure out this math. Okay. 11 goes into 13 once. Bring down the 2, and I know 11 would go into 22 twice because 1 times 2 is 2. Okay. Okay. Now, this is where it gets a little tricky with the rules, okay? We'll probably work on this separate. I don't want to confuse you, but in looking at our expectations, we don't really work with the properties a ton. So that's going to be kind of a separate thing that we will work on. And as we do our vocabulary. Okay, so I don't want you to worry about this. I just want you to answer and know that here is another example if you get stuck, and understand that the division bar means division. So the fraction bar means division rather, so that's the way you would get the answer. Okay, so I'm going to jump all the way to M3 129. Okay, now this one's tricky because we have a fraction again. So working with fractions, we're kind of bumping up that 3 to maybe a 3.5 level of difficulty. Okay. Remember, what I told you in the other video was when I have n over 4, that's the same thing as 1/4 times n equals 7. So we are going to divide by 1/4 and divide by 1/4. That leaves my n by itself. And then I keep change flip to solve this problem. So I keep the first number, but since it is a whole number, I'm going to place it over 1. I change division to multiplication, and I flip the numbers on this fraction. 7 times 4 is 28. 1 times 1 is 1. 28 divided by 1 is 28. Okay, now this one you guys can do by yourself. Okay. This one is going to be hard. Give it a try if you want to. This one has decimals, so I'm going to give that a 3.5 as well. Try it if you can, and you can check yourself with a calculator. Oh, where'd I go here? This one is tricky because it has fractions, decimals. And here, what I've done is on page M3 133, okay, there's 4 practice problems. So you have 1, 2, 3 chances to show me a 3.0. Okay, that's a 3.0. Okay, and then you have 1, 2, 3, 4, 5, 6, 7, all of these, 8, 9, 10, 11, 12 to show me a 3.5. Okay, so work on those. At least do the 3.0. Let me come by and check them. I'm probably going to grade those, and then I'll have a separate worksheet that has more simpler ones like the 3.0 and then a few of the challenge ones so that you can bump your score up if you start to get the hang of those fractions. Okay, good luck and do those practice problems.